Welcome back to the next section of Traefik Training. In this section, we're going to cover services and how we configure services to actually communicate with our applications. And it's going to go deeper into this section, and this is where we really unlock the real potential of Traefik. And we're bringing all the previous topics together into this section, and we're going to continue expanding this by adding load balancers and connecting routers and really understand how this all comes together. All right, so when we deploy a service, regardless if it's one service with multiple instances of our application or just one instance of our application, it comes with a load balancer automatically. So that means when we deploy our service, a load balancer is assigned. It's assigned by default. It gets a default naming convention if we don't define it ourselves. Now, if we scale our application to more than one, so if we scale our application to 2 or more instances, then the load balancer actually routes traffic between all your instances of your application. It does round robin load balancing. And the application is actually called a server in load balancing terms. So in previous world of load balancers where we actually use physical servers, the load balancer would actually connect to a server. So the server is the endpoint where it's load balancing to. And now the server is our application. So that means when the load balancing is occurring, the load balancer is actually routing traffic between the instances of your application. Hence, it's called a server. Round robin load balancing is available with using the same server. If we have different servers, we can actually use weighted round robin, which we'll cover in a different section. Load balancers can also be configured with health checks to monitor the health of your server. So that means we can actually label our service and say we want to enable health checks. We could define the health check period, exactly how to monitor the health. For example, if we want to look at an endpoint /health or /ping, just some examples, or we can actually connect to ports on the health check as well. So we can use port 8080 on your service as the health of your service. So we have multiple ways we can actually check services health, and that's how we do it with the load balancer. Now, if for whatever reason our service becomes unhealthy, the load balancer takes it out of the load balancing and it keeps checking on it. And when it does become available again, it then adds it back to the balancing. And the final thing is a service can be assigned to multiple routers, one or more routers. So just keep that in mind. So we can have multiple rules running, multiple different rule engines running in multiple routers, and we can connect it to the same service. Now, how do we reach services? We love our diagram. So let's look through our diagram once again. So we have the request coming in. We have our default entry points. And remember, entry points are ports. So port 80, 443, or whatever ports we have defined. Next, we hit the router. And this is where Traefik decides, do any of the rules match? If so, then pass the traffic further on. In this case, you can see it passes the traffic to service 1. Service 1 has a load balancer and has 2 servers. So then it load balances the traffic between these 2 servers. Goes traffic 1, 2, 1, 2, 1, 2, and it just goes equally between the 2. Now the other case, the router matches a rule to pass the header, and it just passes it to this server, for example. So you can see we have a lot of configuration possibilities, and to really understand the configurations, I highlighted the top 4 configurations that are used most commonly, I would say, in projects I've done in the past. Now, the first thing is probably the most common label that we add to our service, and that's the load balancer server port. And now this is very important because here's where you define what port your application is actually speaking on. So if it's port 8080 or port 80 or port 5000, you could define that here. The next thing is if we want to pass the host header, we can actually say true or false right here. So that's very important for certain applications that are reading the header information. And then finally, the health check. So you can see the health check, we can define the path, port, and there's actually many more health check options, but these are just the most common that I've used in the past. Now, down the notes of this section, you can actually find the documentation to Docker server service provider, and it actually exposes all the configurations available to the Docker service, and you can actually have some examples in these different configurations, so it's very helpful. And we'll cover these in further detail in the lab, actually. Now, the Docker specific options, this is just for the provider itself, but we also enable these when we start defining our service. So when we define our service in Docker Compose, for example, in the file, It's usually, our image and some other information about the image, the container. And then once we want to tell Traefik to start using this, we need a label that says Traefik enable equals true, for example. And this overrides the expose by default static setting that we saw in the static configuration part of the course. And it then enables this particular application or container to be recognized by Traefik. The next thing is Traefik Docker network. Now, I've done this in the past where I've had multiple networks connected to my Traefik instance. For example, I separate certain customers. So customer A, they all go on network A. Customer B goes on network B. So it's all completely isolated separately, and it's quite nice. So then you can actually connect your container network to this default network, to this specific network. If you don't define a network, it just uses the default network that's available in Traefik, whatever that is. And finally, Traefik Docker LB Swarm. This is actually overriding the Traefik load balancing, and you're telling Traefik, I don't want to use Traefik's load balancing, I instead want to use Swarm's built-in load balancer. So there's certain cases, for example, if you want to expose a port or something like this or some functionality that's not available, or you want to be controlled by Swarm or keep it within Swarm, this might be an option. But now with 2.x Traefik, a lot of these use cases are no longer available or valid. So most like TCP and UDP, you can actually route through Traefik now as well. So this becomes less of a interesting option. TCP, UDP, so everything we do with the service in the labs can be applied to the TCP, UDP. So if we want to deploy a service, you basically repeat the lab as TCP or UDP service, and you can then easily deploy your application as a TCP service or UDP service. Now, it's interesting, it's enabled exactly the same as a normal HTTP service. It follows the same principles, but the configuration is much, much less. Because TCP, I mean, there's very few options. You're basically setting, what ports there, maybe some health checks. That's about it, not much else. And UDP is even less. So still requires an endpoint, and they're configuring the configuration between the two. So if you want to go into TCP, UDP, you can just use the same examples we're doing today, just changed actually entry point to TCP. All right, now the next section is actually all about router and services lab. So we're actually going to take Traefik, we're going to deploy it by itself, we're then going to add a service, and we're going to slowly iterate through each label. So we're going to start deploying labels, we're going to break things, we're going to troubleshoot. It's really going to get interesting in the lab section. So join me in the router and services lab.